Okay, so if f and g are inverses, the fact that they're inverses means that if AB is on F, what's the corresponding point that's on G? BA.
For this video, he started saying this, I would be lost.
Okay, the derivative. So the slope. The first one's easy. That's just the slope of F at A. The second one, the slope of G at B, because we've got to use the x value. How are these two related? This is the word that they're reciprocals. And so that's the big deal. These two values are reciprocals. And like Ty said, you switch the bottom and the top. dy dx, if I switched x and y, would be dx dy. So that's another sort of a tie that they kind of go together. Dy dx in the top one, it's still dy dx for the bottom one, but if you switched it, you get the reciprocal. That's sort of how they go. To me, this is the way to remember it. Like the official formula looks like this. I'll let you decide how you want to think about it. The derivative of g at b is the reciprocal, so 1 over the derivative of f at a. Okay. Those two things say exactly the same thing. To me, I like making the table because then I can keep straight who's A, who's B, where does A go? A goes with F, B goes with G, and then my derivatives need to be flipped of one another. This says the same stuff. It says it a little bit more condensed, but because it's more condensed, it might be more confusing. So, however you want to remember those, again, it's not both and. Those are exactly the same thing. It's just a little bit of a preference of which one makes more sense to you. Obviously, the orange one is shorter, but can you remember what all those pieces mean? The green one slows you down a little bit, but I think it helps you keep track of things. When I work the problems, I'm always going to make a table. Some of you will get to where you're like, I don't need the table. Take a derivative, flip it over, figure out who the switched x and y are. That's a lot to keep up with in your head. I'm going to go with the table route. But if you can go with just remembering that, that's okay. All right, let's do an example. Confused enough?
Yes.
Example, if f of 2 equals 5, you know what? Pause, let's do the table here. So f, g, point, dy dx. So what point is on the graph of f?
2, 5.
Yeah, 2 is the x, 5 is the y, so 2, 5 is the point on f. F prime of 2 equals 1/3. Okay, so the derivative at 2 equals 1/3. Well, before I do anything else, even read the rest of this problem, what's the reciprocal of 1/3? 3. Now I need to be careful to make sure that's what they're asking for. F inverse, okay, I put G, but F inverse is the same thing. That point would be 5, 2, because you got to switch them. So the derivative of the inverse at 5 is equal to 3 because they're reciprocals.
Okay.
So on a lot of these, the math really isn't that hard. Like, can you flip 1/3? Yep. But do you understand what's being asked? That's the hard part. So my answer is that box. So answer A. Well, that one wasn't too bad. Let's try number 2. F of x equals 3x cubed plus 5. Find the inverse at 8. So again, I set up my table with a point and a derivative. We're looking for this value. Right, I don't have hardly anything filled in my table, but I know what I'm looking for. I want to find what goes in that box because I want the derivative of the inverse. The derivative of the inverse. Okay, it gives me that 8. Where the heck does the 8 go?
I have an idea.
Well, is that 8 an x value or a y value?
An X.
An x. An x value for which function? The f or the inverse? The inverse. So that 8 goes right there. Which means what? That means it's also the y value for the original. Which means, if it's the y value for the original, well, I've got the equation. I can figure out what the x value is. So minus 5 divided by 3. So x equals 1. So 1 is the x value of the original. It's the y value of the inverse. I don't really need that, but if I want to fill in the table. So if I only knew what went in this top box, those are reciprocals. So is there a way I can figure out the derivative of f at 1?
Point slope formula?
Not even that. Just take the derivative of this guy. F prime would be 9x squared. Again, that's helping me find the derivative of f. Where do I want to evaluate that derivative?
At 8. Or at 1.
1 or 8? 1, because I'm on this line, so the x value is 1. So f prime of 1 is 9. Is that going in this top box or the bottom box? The top box, because that's the derivative of the original at 1, is 9. So my answer is a 9. I think the table is helpful. It keeps the thing straight. Number 3. Let h be a differentiable function. Selected values of h and its derivative h prime are given on the table at the right. Find the inverse of the derivative of the inverse of h at 5. Well, again, the table. Make a table. Point and derivative. And you can call it, how you label it is up to you, but the point and the derivative. Because again, I think that helps keep it straight. And I already know that those two things are reciprocals of each other. Whatever they are. If I find one, I can find the other one. Okay. So 5. Where's the 5 go? The x value of the original or the inverse? The inverse. Okay, that doesn't really help me because I don't have anything about the inverse of h yet. Where else does the 5 go then? The y value for h. Okay, so it's the y value for h. I would really like the x value that goes with the y value of 5. So if the y value is 5, what's the x value? 10. So I need a derivative of h at 10. I need the derivative of h at 10. What's that equal to?
Negative 1/4.
Yeah, that's the table, negative 1/4. So my final answer then is negative 4. If I flip it over, I get negative 4. If you can do this without making the table, more power to you. I discovered this table thing several years ago, and I mean, it might be an exaggeration to say my life has not been the same since. That's a little bit of an exaggeration. My life on this day in calculus class has not been the same since, because I can keep track of things. Part B, write the equation of the line tangent to the graph. Okay, so I need a point and a slope. But h inverse when x is 7. So again, I know it's tedious to make this table, but and again, every time I make this table, I still put that little, remind myself that those are reciprocals. If I can find one, I can reciprocal to get the other. Okay, what's 7? Where does the 7 go? Is it the x, the y, the derivative of f, of the inverse? It's the x value
Of the inverse.
of the inverse. And I'm looking for this slope because that's the slope that I'll use over here. The point is 7 comma something. See if you can at least get to finding that derivative. Okay with negative 2/3 as the slope?
Yes.
Able to piece together who goes where? So the slope we're using, because we want to tangent to the graph of the inverse, so we use the slope of negative 2/3. And the point is 7 comma 3 because the x and y trade places. And so now it's just y minus 3 equals negative 2/3 x minus 7. Preston, you good? Okay. Where'd the 7 and 3 come from?
I forgot where the 3 come from.
Okay.
Now I know.
Okay. Thank you, Kate. Let's try one more. The last one is just another table problem, but let's try number 4.
This looks scary.
Again, yeah, there's lots of symbols, numbers, letters all over the place on this one. Okay, if G is the inverse of F, so I can set up my table as F and G, they're inverses of each other. I know there's a point and there's a derivative involved. Okay, I want the derivative at 1/2. So again, where does the 1/2 go?
G's x.
Yeah, it's the x value for G, which means it's the y value for F. Okay, so y value for F. I don't have a table to look at.
Plug it in. Or
Yeah, I'll plug it in. Make sure you plug it in for the y value. Let's see. So sine of 3x equals 1/2. Well, where does the sine equal 1/2?
pi over 6.
So that means 3x needs to be pi over 6. Which means x needs to be pi over 18. It's probably not necessary at this point, but I'll remind myself that If I can find one of them, then the other one is just the flip. Okay, I don't really know anything about G, so that's what I want to know, but I think I'll have to get it by flipping the derivative of f. I don't have a table, don't have a picture,
So we're gonna have to flip it.
but I do have a formula for f, so I can find the derivative based on that formula they gave me. So derivative of sine is cosine, and if I write cosine of 3x, I'm wrong.
You need multiply.
Chain rule, I need a 3 on there. Okay. So what? What next?
Do you plug in the x at pi over 18?
Yep, I'll plug in pi over 18. That will tell me this slope. Then I'll flip it over to get the slope that I want, to get the derivative that I want. So f prime of pi over 18. That looks terrible, but we're going to multiply it by 3 in a minute, so it'll be okay. So 3 cosine pi over 6. Cosine pi over 6 is root 3 over 2. So that slope, the slope of f at pi over 18 is 3 root 3 over 2. Man, we've done so much work, it's really tempting to circle answer choice C.
No, you have to flip it over.
I gotta flip it though. Don't be tempted. Gotta remember to flip it so it would be answer choice D. You also notice that we didn't even fix it. We just flip it and we're good. Okay, kind of confusing. Draw the table, draw the table, draw the table. Don't try to do all those steps in your head. It's just too much. It's just too much.
We'll make a mess.
Show the steps, draw the table. All right, we've seen everything that's on the test now. So, again, if this is confusing or if there's more things you're worried about, we've still got Monday and Tuesday of next week to hope it
Wednesday.
sinks in.
And Wednesday for us.